Okay, in the last video, we have configured the router RIP on all the three routers R1, R2, and R3. They are all running version 2, and basically the network command is only one single command. That means anything that starts with 192.168.6, you'll be included in the routing updates. So this is my entire 192.168.6 network. Okay, so after configuring the RIP, PC1, PC2, PC3, which is in this network, are able to ping each other. Okay, what we are left is only the internet. Okay, so if you remember, the internet contains millions of networks, and the ISP will not share the IP address of this network with you. ISP basically don't send routing updates to you, you don't send routing updates to the ISP. So how you communicate with the ISP is normally using default route or static route. So in this case, we shall use a default route for our internal network to go to the ISP, and we shall use a static route for the ISP to connect to your internal network. Okay, first let's look at R1. For R1, okay, R1 already have the route to all the 192.168.6 network. So we configure a default static route, okay, telling R1 if R1 receive a packet and it's not and this packet do not goes to any of the 192.168.6 network, okay, he should send the packet to the internet. How should he send the packet to the internet? He should just send the packet out through this interface and then go to R3, and then R3 will help R1 to route the packet to the ISP, which then connects to the internet. So we shall configure the IP route, the default static route, which is 0.0.0.0, 0.0.0.0, and the exit interface G01, which is here G01. Okay, so you send the packet out through the G01. Okay, let's configure this. Okay, I'm just going to copy this and paste it on the router. Okay, so we have the default route. Okay, okay, we received this message saying that default URL gateway, if not point-to-point, may impact performance. Okay, this is a very good point, because actually exit interface is not a very good way to specify as compared to the next hop IP for this case. Okay, this is because, okay, if you notice, if I specify the exit interface to be this, okay, this is not a point-to-point connection. This is a point-to-multi-point connection. Meaning, okay, when the packet exits out here, it can either go to PC3 or R3. So where should it go if I specify this as the exit interface? So that's why we see this error message, or not really as an error message, this warning message. Okay, so for this case, okay, actually the better way is to use the next hop IP, okay, to tell the router send it to R3, this interface. Okay, the R3 G00 interface IP address. Okay, so okay, for this case, okay, let's remove this. Okay, and then we should use the next hop IP. Okay, for R3 G00 interface is the 192.168.6.130. Okay, we should use 192.168.6.130. Okay, this should be a better way to specify the default route as compared to the G00. Okay, this will also work, but it may impact performance, meaning sometimes the packet may not be delivered to R3. Okay, it may be delivered to PC3. So we should use a next hop IP, which is more specific. Okay, so that's for R1. Okay, let's close R1. Okay, for R2. Okay, R2, the default static route should point to R3 too, because when the R2 receives a packet, it's not going to any of 192.168 network, it should pass it to R3, and R3 will help you to pass it to the ISP, to the internet. Okay, so for this case, can we use the exit interface? Yes, because this is a point-to-point network. So for point-to-point network, we are able to use the next hop or the exit interface, because for this exit interface, there's only one place to go. That is R3 here. So you can use the 0000 as exit interface. Okay, let's go ahead and configure for R2. So same thing, IP route. Okay, serial 0, 0, 0 as the exit interface. Okay, it will prompt you for the same warning, but for this case, we are sure it's a point-to-point connection, so we can ignore the warning. So now R2 will use 0, 0, 0 as the exit interface for the default route. Okay, finally, R3. R3, if they receive a packet that's not going for the internal network, it should pass it to the ISP. And since this is again a point-to-point network, okay, we can use the 0, 0, 0, 0 as the exit interface. Okay, so let's go ahead and configure for R3. Okay, so same thing, 0, 0, 0. Okay, and the exit interface. Okay, so we see this warning which you can ignore, which is because this is a point-to-point connection. Okay, so now PC1, PC2, PC3 can send the packet to the internet because R1, R2, R3 know how to route packet to the internet. Okay, so what is PC4 IP address? 200.10.10.2. Okay, let's try to ping. Okay, so when you ping, you notice the ping will fail. There will be a request timeout. Okay, why does the ping fail? Okay, when you try to ping, okay, although we have already configured the default gateway or the gateway of last resort. Okay, the reason is because okay, PC4 in fact will receive the packet when PC1 try to ping the packet. So when PC4 try to reply back, he will reply back to the default gateway. When the ISP receives the reply, he's supposed to send the packet to PC1, the 192.168.6.100. But in the routing table of the ISP, okay, it doesn't have a route to go to the 192.168 network. So we also have to tell the ISP how to route packet to the 192.168.6 network. Okay, so looking at the lab sheet, okay, the ISP will also need a route to the 192.168.6 network, and it will use the exit interface serial 001, which is over here. So telling the ISP, if the ISP receive a packet going to the 192.168.6 network, pass it out through 0001 to R3. Okay, let's configure this static route. So any packet going to the 192.168.6.0 network, okay, this will be the subnet mask. I shall send it out through my serial 001 interface. Okay, with that, let's see if the ping will work again. Okay, now with the static route configured on the ISP router, PC1 is able to ping PC4 on the internet. Okay, so we can try this on PC2. Oops, okay. Let's do the ping again. Ping 200.10.10.2. So PC2 is now also able to ping PC4. And finally, PC3. So the ping also be successful. So with that, we have configured the three type of routing protocol. First is my router RIP, dynamic routing protocol, for routing between the PCs in the 192.168.6 network. Next, we also configure a default route on the router to send unknown packets to the ISP. A packet that's not in part of this network. And finally, on the ISP, we configure a static route, okay, that points to the 192.168.6 network. Okay, and the packet will be passed to R3. Okay, so this concludes this lab, and okay, and then from this lab you have learned the basic technique of designing IP address scheme and also combine the use of static route, default route, and dynamic route.